Medicine has advanced greatly in the last century. We have developed new ways to better diagnose and pinpoint the underlying causes of diseases and treat them. At the root of our ability to care for our fellow humans is technology. Technology that allows us to peer into our organ systems with greater clarity than ever before, to not just see anatomy, but also physiology.
Think about the sophisticated array of tools the physician could use to reach intricate parts of the body, or long-lasting artificial organ implants that serve as substitutes for essential parts of the body, or tissues that can regenerate themselves. Medical technology also includes software tools that we can use to interpret the vast and complex information we collect, to discover the underlying causes of ailments such as genetic predispositions, or to develop personalized therapy for patients, and ultimately enhance the quality of our lives.
But where does all this technology come from? Who thinks up and develops these fascinating constructs? How do we manufacture them with the quality controls needed for the human body and make improvements to design based on patient outcomes? And not to mention, do all that in an affordable way and make them available to patients in a timely manner? Welcome to the fascinating world of biomedical engineering, where we seek to leverage the principles, methods, tools, and techniques from engineering to improve human healthcare.
A degree in biomedical engineering involves the study of the fundamentals in all disciplines of engineering and their application in the unique landscape of medicine. Students start with courses like math, physics, chemistry, and biology, followed by courses on their engineering applications in mechanics, circuits, and thermodynamics. These lead to courses that provide a broad overview of biomedical engineering. Courses like biomechanics about human motion, posture, and blood flow in the heart. Courses like biomaterials about the science of cell-material interactions. Courses like bioimaging about how scanners work. Instrumentation about making measurements in biological systems. Bioinformatics about big data processing such as genomics. And the quantitative features of cell biology.
From this broad perspective, students then choose to specialize in tracks such as biomechanics and biomaterials, bioimaging, cellular engineering, and bioinformatics. They will then have the opportunity to delve deep into these tracks through specialized courses offered by faculty on the science and engineering aspects of diseases, medical device design, quantitative biology, medical diagnostic instrumentation and data processing, probabilistic statistics, and software design, culminating in a senior design project. In this one-year capstone project, students pick mentors outside the department, such as faculty in the Carver College of Medicine, to work on projects developing and designing practical solutions to real-world needs. Projects such as the design of a device to remove mucus from the lungs of a cystic fibrosis patient, a novel process to reduce contamination during plasma infusions, or an app to improve communication among doctors and patients.
Along the way, students may also leverage opportunities for extracurricular development, such as working in research labs directed by biomedical engineering faculty, internships or co-ops in the industry, leadership opportunities within student organizations, and teaching assistantships in the core engineering courses. At the Roy J. Carver Department of Biomedical Engineering at the University of Iowa, students get to learn from faculty with a broad range of expertise within biomedical engineering. They design many of their courses around their research to provide exposure to cutting-edge topics in the application of engineering to medicine. Topics such as the development of artificially engineered skin for burn victims, orthopedic implants, sophisticated cell analysis systems, artificial intelligence algorithms to rapidly detect the severity of lung disease, and stem cell therapies for diabetics.
They also include biomolecular computer modeling to study drug tablets, computational biology to delineate genetic predispositions in diseases, and the development of computer models to simulate human motion, novel MRI imaging to assist speech therapy, and microfluidic devices for developing drug therapy.
Let's hear from the BME faculty and staff. Hi everyone, please tell us what you do and what your interests are.
Hi, I'm David Wilder. I'm interested in biomechanics and I'm interested in my
Okay, so I guess, as they say in Silicon Valley, it's not a bug, it's a feature. Our faculty and staff are just very passionate about what they do. Let's try that again.
My name is Nicole Calamine, and I'm instructional faculty here in Biomedical Engineering, and I teach in the area of orthopedic biomechanics and the materials that we use inside the body for different devices.
Professor Teung Lim. Just my interest is to find the relationship between the disorders in the spine and the control of back muscles.
My name is Osama Sala. I'm an instructional faculty here in the area of bioimaging. If you're ever interested in learning how to start building an EMG or an ECG, welcome.
Sarah Bingstead, cardiovascular fluid mechanics.
Hi, I'm David Wilder. I'm interested in spine biomechanics and ergonomics. I've been here since 1994, and I try to see how people respond to surprises, say being kicked in the butt, and try to incorporate those findings into national and international exposure standards.
Yeah, my name is Terry Braun. I teach software and bioinformatics. My research interests are in using informatics to analyze DNA and genomics data.
Hello, my name is Sajan Lingala. I teach medical imaging, and my specific research interest is developing novel quantitative and rapid MRI methods. And I look into novel diagnosis and treatment imaging strategies in things for the airways, such as sleep apnea and swallowing disorders.
Hi, my name is Joe Reinhardt. I teach classes in computer programming and electronics, and my research area is medical image processing.
Hi, I'm Suresh M.L. Raghavan. I do research and teach in biomechanics, which is the study of forces and motion in biological systems. In my laboratory, we use biomechanics to develop tools for plumbing the human body, specifically devices of the heart and the lungs.
I'm Kristen Worthington. So I teach classes related to human cells and material science, as well as how the two connect with each other. So these are also the same types of things that I'm passionate about in my research. So first, understanding how the structure and the stiffness of materials can affect cell behavior. And then secondly, how we can use that to our advantage by designing materials that work together with cells to regenerate human tissues.
I'm Josh Lopp, and I provide administrative support for both the undergraduate and graduate programs.
Hello, I'm Professor Michael Mackey. For my research, I've studied cell cycle regulation at the cell and molecular level using standard wet lab technologies. I've also developed live cell imaging techniques to supplement those studies.
Hi, my name is Sathival Chinnathambi. I go by Sathi. I'm the instructor for cell biology and cell material interaction. I enjoy teaching lab, and I like answering to students' questions.
My name is Nicole Grassland, and my area of interest is musculoskeletal biomechanics.
My name is Jennifer Waite. As the department administrator, one of my favorite things about our department by far are our faculty and our students who are not only thinking about making a difference, but they really are. We have some of the most committed, dedicated, enthusiastic faculty, and that's one of my favorite parts about my job.
Hi, this is Kareem Abdul Malik, and I do research in human modeling and simulation.
Hi there, I'm James Ankrum. I love talking to students about research and how they can get involved.
Hi, my name's Ed Sander, and I'm an associate professor in the Department of Biomedical Engineering at the University of Iowa. My lab's interested in using mechanical and chemical cues to direct cell behavior so that we can do things like improve wound healing and replace diseased and damaged tissues.
Hello everyone, my name is Yuliang Xie. My research merges engineering with medicine. I aim to using microfluidic devices to solve the problem in airway physiology and pulmonary disease. Thank you.
Hi, I'm Professor Tom Cassavant. I'm in the area of bioinformatics and computational biology, where I do research. I teach courses in that area, but also teach courses in software engineering and high-performance computing.
Hi, I'm Colleen Brigman, and my area of interest is physical therapy and rehabilitation science, particularly medical device design.
My name is Professor Michael Schneiders, and I'm a joint faculty member in biomedical engineering and biochemistry. My lab focuses on biomolecular engineering.
My name is Seth Dillard. I've been with the BME department since 2015, and I love teaching people about the heart.
What do students do after graduation with a BS in biomedical engineering? Typically, a third of our students start careers in the industry, joining large, medium, and small biomedical device corporations, where they get to design, develop, or test medical devices, at hospitals as biomedical engineers, engineering consulting firms, or medical imaging and software companies. Another third go on to pursue graduate studies, often in biomedical engineering, but sometimes in other affiliated disciplines that leverage their training. Students have gone on to pursue graduate studies in such disparate areas, such as business administration, health administration, medical physics, and law. Finally, a rough third pursue further studies in medicine. These include MD programs, but many also include dental school, physical therapy, nursing, physician assistant programs, and other medical specialties such as perfusion programs. Let's hear from some of our current students.
Hi, my name is Joseph Varian. I'm a third-year biomedical engineering student here at Iowa on the pre-med track. I've been involved in research and volunteering with the mobile clinic here, but also involved in the student government and the Homecoming Executive Council as one of the parade directors one year. And after I graduate, I plan to apply and attend medical school.
My name is Ashrita Raghuram. I've had the opportunity to study abroad with Chimba, Italy, complete an engineering co-op with endoscopy R&D at Boston Scientific, and complete research at the University of Iowa Hospitals and Clinics with the departments of neurosurgery and neurology. I'm looking forward to continuing my research after I graduate this December and hopefully attend medical school.
Hello, this is Marco Nino. I'm a Bachelor of Science graduate from the BME class of 2019. During my undergrad years, I did research in 2 different research labs. That experience ultimately convinced me to pursue graduate school. I am now a Carver Fellow graduate student here in our department. For my PhD, I combine principles from electrochemistry and fluid mechanics to develop a novel device that is placed between the heart and the lungs to measure blood flow.
Hi, I'm Hayden Gavette. I am a third-year BME student here at the University of Iowa. This summer, I was fortunate enough to work for Vita Diagnostics as a precision analyst intern, in which I analyzed CT scans to create 3D models of the lungs. After graduation, I'm hoping to do something along the lines of medical device design, such as prosthetics or orthotics. Thanks.
Hi, my name is Pareen Matre, and I am a third-year biomedical engineering student on the biomaterials and biomechanics track. Over the past couple years at Iowa, I've had the opportunity to work in the Biomost lab here at the BME department. I volunteered at the hospital, and I've worked for a university-affiliated medical device company where I help with manufacturing of face shields. After graduation, I hope to go to grad school to earn my master's. In the College of Engineering at the University of Iowa, one can expect a dedicated faculty and staff and a collegial student body in a close-knit community that is grounded in the Hawkeye spirit. Let's end with a message from our department chair, Professor Reinhardt.
Hi, my name is Joe Reinhardt. I'm the chair of the Biomedical Engineering Department. I got interested in biomedical engineering because I was fascinated by the idea of using computers and medical imaging devices to study the inside of the body. Other faculty work in the area of medical devices, heart valves, and prosthetics. Still others are developing cell-based therapies or studying human genetics or trying to understand and cure cancer. And these are just some examples. There are plenty of opportunities in biomedical engineering. We think a BME degree is a great gateway to a job in industry, to admission to medical school, or maybe graduate school and a future research career. Thanks for learning about biomedical engineering, and good luck in your career at Iowa.